So if you're in the DC, Virginia, or Maryland area, Danny Blue and I are going to be at DevFest 2014 in AOL's headquarters in Dulles, Virginia. We're going to be working with Jeff Posnick from Google, and we're going to be talking about web components and Polymer. We'll do a short little intro and Q&A, and then we'll go right into a code lab. So if you're interested in learning about Polymer, learning about web components, and just having a great time coding and then learning new stuff with Google technologies, come on over to DevFest. That's at AOL's headquarters in Dulles, Virginia. Hope to see you all there. Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond. This is episode 18 of the Web Platform Podcast. Your hosts today are myself, Eric Isaacson, UX engineer at 3Pillar Global, and Christian Smith, open source developer and startup enthusiast. Today we're going to be talking about WebRTC. We're going to take a deep dive and look at VoIP, WebRTC, getting WebRTC to work in different environments, and do more of a deep dive than our previous episode we did on WebRTC and real-time, which was a great episode, and we learned quite a lot. But we wanted to take a deeper dive and look into the intricacies of working with WebRTC today and what we can kind of foresee in the future, given that ORTC was recently released, which is the newer version of WebRTC. I think WebRTC 1.1. So today we have the unofficial guru of WebRTC online is Tsahi Levent-Levi, and he is joining us from Israel today via Google Hangouts. So welcome, Sahil.
So it's 9 p.m. here, nice and cozy.
Sahil, we've been reading a lot about WebRTC, and every time I look up something on the internet dealing with WebRTC, in the top Google searches, you always come up with some blog or some Google Hangout, something on there that ties to you and WebRTC. So can you tell listeners out there what you've been up to, what you do, and why WebRTC is important today and how you use it? I know it's a lot, but can we go through just some of the basics first and who you are?
Yes. My name is Tsahi Levent-Levi. I started, I think, around 16 years ago when I started working at RadVision. It's a company that was acquired since then. But essentially what the company did then was build video conferencing systems. In that company, I was in the technology business unit, which ended up selling protocol stacks to companies that wanted to build voice over IP solutions. So if you wanted to build a voice over IP phone or a PBX or a testing tool or whatever, you'd come to RadVision, license a protocol stack from us, SIP or H223, and go build with it whatever you wanted. So I started there as a developer, then managed other developers, moved to product management, and I left as the CTO of the business unit. One of the reasons I left 3 years ago was because of WebRTC and the fact that the company at the time didn't want to invest in it. At the moment that I saw it begin, I said this is something that we must look into and must check, because this is going to be the future, and I didn't get the budget to do that. So I understood that as a CTO in a company, if there is no investment of what comes next, then there is no future for you in such a place. So I essentially left, went to work on a totally different area in Amdocs for BSS systems, and in the past year I've started doing consulting around WebRTC and voice over IP in parallel to my work at Amdocs, and that happened because I opened a blog of my own, a blog Geek Me, where I started writing about technology and a bit about WebRTC. The posts on WebRTC were so popular that I ended up writing mostly about WebRTC at the end of it. And that became the reason I could actually go out and consult about something that I feel passionate about. So let's start from 5 years ago. Let's say you wanted to build a video conferencing endpoint or system or solution or service. Call it an over-the-top Tango or Viber or whatever you want. You look at what you need to build. You need to offer two things. You need to deal with codecs to actually be able to encode and decode the media that you're going to send. Okay. And then you need the signaling part and the transport, sending that data over the network and then deciding who needs to call whom and when. So as a developer, you go out, you look look at options that you have available. Developing such a thing on your own is pretty hard. It's really challenging. So you go and license something called the media engine. A media engine essentially takes the codecs, pairs them with the devices that you have. So it connects to the microphone, the speaker, the display, the camera. It encodes, and for that it either does that using software or rides on top of the hardware that you have that enables that. And then it deals with sending this stuff over the network. So it will take care of problems like packet losses on the network. It will either retransmit or try to conceal these packet losses or send extra data in a way that is called forward or correction. It will do a lot of neat stuff in terms of algorithms to make sure that the voice and the video actually passes through. Okay. Now the problem is that if you wanted to license such a thing, the cost would be anywhere between $50 to $2,100 just to get a piece of software that you embed in whatever device you want to use. Then you need to pay royalties for the codecs because they are patented, royalties for the company that gave you the media engine because that's their business model. And you're looking at something like, if you want to build such a solution, you need to start with $1 million investment in everything related to this development to begin with. So you have an idea, you need a VC, and only then you can get money and start building. That was a few years ago. Now what WebRTC did was say the following: let's take the media engine, the ugly part in the low-level ugly part of the solution, and let's put it inside the browser with an API that everyone can access and use. It is today available on Chrome and Firefox and Opera. Microsoft announced that they will support it in its next variant called ORTC a year or two from now, who knows, in some future version of Internet Explorer. So it's there, you can use it. We're actually using it now, by the way. So I have Hangouts running here on an Ubuntu machine. It's running WebRTC inside the browser, Chrome, and we are using WebRTC to do this session between us, running inside the browser. Google simply had that in there. So now as a developer, you get a media engine with a JavaScript API on top that you can just start using for free. So it reduces the cost for the developer. It reduces the effort that is required to build such a solution, especially because I don't need media engineers, there is no royalties involved, totally free. It commoditized the media engine part of building a communication product. That's what it does for the developer, so it lowers the barrier of entry dramatically for new entrants. On the other hand, if you're a user, well, you don't need to install anything now. You can just go to a URL or put an app on your phone. That's installing, but that's another way of consuming today's services on a mobile device, and it just works.
Magic.
Yes. You wouldn't believe how much magic it is if you had built something with voice over IP before that.
So let's talk about voice over IP. How are companies using this? Is it just web applications that people are building, mobile applications, or is it some, internal mixed hybrid type of technology stack?
It's WebRTC today goes everywhere, because one thing that I didn't mention, WebRTC is actually two separate things that we're talking about. The first one is a specification. The IETF and the W3C went and said, well, this is WebRTC. This is what goes on the network so that two client servers, whatever, can understand what it is that they're receiving or sending and agree on that. And then there's the WebRTC open source project in WebRTC.org, which is the implementation of WebRTC that can be used anywhere. So now if I'm a developer and I have a solution of my own, and the only thing that I need is a media engine, or even just the echo canceller, or the specific codecs that is used by this project, I can take that code and embed it in my own code. And there are companies that are doing just that with WebRTC. But at the end of the day, it fills a gap that they had in their solution. Instead of going and licensing an echo canceller, which cost me money, I get one for free. I need to build a mobile app that allows doing a video conference or video call. I take WebRTC, I port it and use it. Who cares if it runs in the browser or not? Without it, it would have cost me a lot more, both in time and money. And then you see a lot of different solutions come out there. Some of them will be, well, we're a traditional company, so we're doing video conferencing. We run with large room system solutions and MCUs, but we want to enable access into our network through a browser. So we had WebRTC to that. Others will say, well, we're running telecom stuff, so we do phone calls and we now want to be either reachable or dial to the browser. So you see people add that into telephony. Others will come and say, well, the only thing I want with WebRTC is to be able to get two people to talk to each other because it's a dating site. And I want them to be able to do that in my own terms and not to send them to phone numbers, because then they stay within my own closed garden and I control the whole process and the whole experience for that person. So you will see a lot of different uses made with WebRTC.
So recently, Within the past, probably, I don't know, 8 months or so, I did have a chance to sell WebRTC to a client. They wanted to do something similar to what Apple does on, with their concierge service, but they wanted to do it online, something like Mayday. And the thing was that they needed to support older browsers. They needed Internet Explorer in particular because it was their internal system. So what happened is it was very difficult to sell them on the technology piece of it because it just doesn't cover that browser breadth. So what you're saying is, and correct me if I'm wrong, please, some of these companies are just basically to offset that, wrapping this in some desktop application or some other more closer to the OS level type of application.
So there are several options there. The first one is saying, well, I couldn't care less. Okay. There are those that do that. I'll give an example. If I'm a company and what I want to do is, I'll get to your use case in a second, but let's say that I'm a company and I'm selling online. I'd like people to be able to text chat with me and if possible to make a voice or video call because I'm trying to sell them stuff. So I want to reduce friction and make sure that they have as little as possible to decide and think on their own and to reach out for me as fast as possible. So if they're using Chrome, they will see this button that allows them to video call me or to voice call me. And if they're not on Chrome, I'm not going to show it to them. So some will get a reduced kind of an experience, but that's what they're getting today already. Mm-hmm. Okay, so I'm going to improve the user experience to some of my potential customers, which is good enough for me. The other option is to say, well, we're going to put a plugin in there. So, well, before we used Google Hangouts, it had the plugin. If you want to use Skype, you need to download it. So I'm going to do the same. Go to URL. If you are coming from Internet Explorer, I'm going to ask you to install a plugin. You install it, hopefully, and then you use it as if WebRTC is running on Internet Explorer. Up until a few months ago, you had to build that on your own, to wrap WebRTC as a plugin on your own, or to use a third party to do that, in terms of a full platform that, by the way, already has a solution for Internet Explorer. But today, another option is to just go to Temasys. Temasys is one of the WebRTC vendors out there, and they're now providing their plugin for free. So you can use their own plugin through their own CDN or pay an SLA to get that and customize it the way you want to.
Interesting. So does that work with like mobile Safari and mobile WebKit too?
No, it works only on Safari for desktop and Internet Explorer.
Okay. That's still something though. That's pretty awesome.
Yes. Or you can, decide not to use WebRTC. That's also a solution.
Right.
But then what do you use instead?
Yeah, that's the thing. There's so many custom solutions that everyone's building out in native platforms, and so they're repeating a lot of the same code over and over again. So it would be nice to be able to use some web technology or something that would unify everything.
Now, you mentioned the mobile Safari. So the problem with iOS, well, there are two problems with mobile. The first one is nobody uses the browser. So for most use cases, it's going to be useless anyway. You need an app. There are some that would say, well, if I'm a website that sells stuff, I don't have an app on the phones of my potential customers. They're drive-by customers. So yes, you need that, but then iOS is out of the question today. If you need an app anyway, then you can port WebRTC to that mobile device and wrap it into your application. There are those that enable that using PhoneGap or other mechanisms that allows you to wrap an app with WebRTC, either native code or with HTML5 code, whatever you like. So it's a matter of finding the right solutions.
So one of the things we talked about before the show too was, should I buy or build? Can we talk about that? How much should developers bite off, or how much should they service out some other vendor for this sort of use case?
I'd say that there are two options here, or let's say two key parameters of should you buy or build. The first one would be how much NIH do you have in your DNA? Not invented here. Okay, the more you like building on your own, the more you will end up building on your own with WebRTC as well. And the second one is how core is communication to what you're trying to do. So if you're running a contact center, I would argue that communication isn't the core of what you're doing, as stupid as that may sound.
No, it doesn't sound stupid, but the question would be, what kind of communication can we do it in a more, versatile way than WebRTC or something else? Or is WebRTC be the most versatile way?
It's just another tool in the toolbox that we have.
Right.
And then again, the question is, what is it that you're trying to build and how would you like to build it? So one option is build it on your own from scratch. Start from nothing and build. Look for demos on the web and, copy paste code. It works. There are people that are doing that. You can decide to use frameworks that are out there as well. So if you're looking for a signaling solution frameworks, you've got simple Web RTC, easy RTC, peer.js, RTC.io, okay, just to name a few. So you can take any one of those, all of them open source, and just start using them and build on top of them whatever it is that you need. If you are coming from the voice over IP domain and what you need is, let's say, connectivity to SIP or SIP trunks or coming into a PBX or connecting to telephony, then you probably will end up using Asterisk or FreeSwitch. These are open source PBXs or media servers that run in the voice over IP domain, and they also offer today connectivity to WebRTC. So you'll probably use that as the basis of what you do on the backend. Then you can go and say, well, I'm lazy. I don't want to maintain anything, to install anything. What I need is software as a service. And then you can go in one of two routes. The first one is say, I'm going to split it into pieces. So for example, if the only thing you need is someone to handle NAT traversal for you, okay, WebRTC requires to pass NATs, network address translators and firewalls. In order to do that, it uses protocols called stun, turn, and ice, and that essentially requires installing or maintaining stun and turn servers. So either you do it on your own, find free ones on the internet, or use Circis, a company that essentially sells you a service of NAT traversal. You connect to their servers, you pay for it monthly, and that's it. Another option is to go to Pubna, Pusher, or Firebase, and they provide signaling, not only for WebRTC, but you can use it for WebRTC. And a lot of companies are using them for signaling.
So how does that work with signaling?
It doesn't. WebRTC doesn't include signaling. It's a media engine. It's bringing your own signaling.
No, that's what I mean. It's like, how would you go about integrating it?
Well, you decide what you want first. So let's say that you want to connect to telephony. You probably would require SIP signaling somewhere. So either use a gateway to connect there, or use SIP over WebSocket inside the web browser, and the PBX already knows how to use a PBX. It knows how to use SIP over WebSocket. Now you can say, well, I already have presence in my solution. I'm using Jabber for instant messaging in my service. I'm called Facebook, and that's what they're doing. They're using XMPP. So for them, it would be easier to just use, XMPP and put WebRTC on top of it in terms of signaling. Another option can be, I couldn't care less. I'm going to build my own solution, and that's it.
Could you give us kind of a high-level picture of how the architecture of a WebRTC application works? Like, for example, we're using it now with Google Hangouts, and so there's a server-side component involved, but then there's also, correct me if I'm wrong, a peer-to-peer relationship between the clients.
Yes, it won't be so easy to draw that or picture that through voice, but let's try. So essentially, voice over IP, and not only WebRTC, is usually built by a triangle. You have a server. The server communicates with both clients that are on the call. It can be two or more, but let's take the easy option of two clients, and all of the communication, or let's say all of the negotiation for the call, begins through the server. So if I want to call you, I'm going to tell the server, I'm looking for Christian. Where can I find him? Is he available? And then the server knows where you are. He's going to connect you and say, Tsahi is looking for you. Do you want to talk to him? You say, okay. The result comes back, and then we start talking directly to each other, and that becomes the other leg. So in voice over IP, these triangles are common. You do a call, you can say that they are either done peer-to-peer, or there is a server that manages the actual media as well. It depends on how the network is architected.
Nice. So does the server typically manage your authorization for that?
Yes. Okay, now there is this problem of media, because I can't send media directly at all times. There might be network address translators that are going to make it hard. So on the web, if there is a server, the browser is always the client. Whatever happens, the browser needs to connect to the server. So there is always a pinhole that goes through the firewall, and it is left open. It's not the case when you send voice and video. There is no request response going on for the actual media. Okay, so at times you need to be able to either relay the media or try to open additional pinholes in the browser. And for that, you have technologies called stan and turn. So stan is a web server that essentially answers a simple question: what is my IP address? If I'm behind the firewall or not, and most of us are, either because we were behind the Wi-Fi access point, an ADSL box, or whatever, or inside an enterprise, we have a private IP address. And if you want to send me data directly, you need to know my public IP address. But in order to know that, someone needs to tell you that. And well, you know what? I don't know my public IP address. My machine only knows the local one. So in order to know the public one, so I can tell you that, so you can send me data, I need to first go and find my IP address. And I do that by going to a stan server. I go to that server, I ask him, what's my IP address? It returns back what he sees from the network. And now I can give it to you to try. Sometimes it works, sometimes it doesn't. When it doesn't, we might need to relay media. And relay media means that we have a turn server. And now whatever I send to you is not really peer-to-peer, because it goes through a server that relays everything between us, because that's the only way we found to reach out to each other. Okay, so there's a signaling server that does whatever it wants with WebRTC. We use it simply to communicate the fact that we want to talk and how we are going to do this session. And then the actual media can be sent either directly peer-to-peer. I can use stan to find these addresses, and if that doesn't work, it will go through a turn server. So there are multiple servers involved. This is why when you begin a call in WebRTC, after you go and decide what you want to do and tell the browser, well, I want only voice, or I want voice and video, and this is the resolutions I need, blah, 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 blah. What you actually do is we say, this is what I want to do, which ends up being an SDP. And in WebRTC, there's this thing called the peer connection. It will create the SDP for you, okay, the session description. And that SDP is something that I need to pass to the server, and the server will pass to you. Once you see that SDP, you will send me back your SDP. And with that, we will start our negotiation. After the negotiation successfully ends, we have media passing between us either directly or routed through a turn server.
All right, so if
Does that make any sense?
Yeah, I think so. If I understand it correctly, you're going to go peer-to-peer whenever you can. And then if you can't, your client, your browser, is going to say, hey, server, I need to talk to this other person over here. Can you get their IP address? And so that stun server, in this case, would say, let me see. And if it can't, it's going to go to this other server or other piece called turn that's going to do what exactly again?
Relay the media. I'm going to send the media to that server, and that server, without looking at the media, is going to send it to you.
Okay. So this is how you're going to get like live video, live chat, stuff like that, if you can't go peer-to-peer, right?
Yes.
Okay. Is that different as far as performance?
Yes. It's first of all, there is added latency because there is another leg in the call now, another component that needs to be handled. There is an issue of an architecture. If you're in the US, I'm in Israel, and the server that you use to relay is in Japan, we've got a problem. If both of us are in France and the server in the US, we have a problem. Okay, it is going to add latency and packet loss. And then there's the issue of cost. A turn server is expensive, not because it is, it's not interesting, but it requires a lot of bandwidth and a lot of CPU. So it's a resource hog. Think about video calls. Video calls, they are something like a megabit per second, bidirectional.
Yeah.
Okay, so if you need to do one call, that's nice, it's easy. But if you want to scale it to 1 million calls in parallel, that's going to be a real headache.
Yeah, I could see that.
Does WebRTC, does the protocol itself say anything about these negotiations, about how to authorize them or how to secure them?
Authorize? No, it couldn't care less. You do that on your own for whatever it is that you need. Secure them? That's a different story. In voice over IP, it's funny because when you look at voice over IP, so there's how you communicate. It's always done in the clear, and then someone looked at it and said, "Hey, we need to secure it. Let's add security." This is how it usually looks, and you end up with deployments that are unsecure most of the time. WebRTC went to the other opposite, to the other extreme. In WebRTC, the media itself is always encrypted. Period. There is no way to send the media in the clear. So to begin with, at least the communication is secured. The question is signaling. Is the signaling secure? Well, it's up to you as a developer. But WebRTC is making sure that you're going to end up using TLS. And it does that by doing something very simple. example. When you use WebRTC, if the page that is running the code uses HTTP and not HTTPS, it will always ask you before it gives you access to the camera or to the microphone. Always. If the page is under HTTPS, it will ask you only once, and then the browser will remember the choice.
So if we built apps with WebRTC and underneath we're using HTTPS, it won't even ask you? It'll just activate those APIs?
It will ask you once.
Oh, okay. I was like, wow, that's creepy.
And that's it. Only once. Okay, now if you press F5 on the page to refresh it, it will ask you again if it's HTTP.
I see. That makes sense.
Yes. So you see, when you look to, if you go to a service that runs WebRTC, the first thing to notice if they're only playing around if it's HTTP, they're serious if they're HTTPS. So that's the first signal.
So I'm looking through, is WebRTC ready yet? And we're looking through all the different APIs and the different pieces of WebRTC. Can we just go through some of those APIs and talk about how you're using these pieces inside of your consulting work, or how developers can start implementing a lot of these?
Usually I don't consult on these the bits and pieces of the technology. I usually go to the larger picture, either of the architecture,
right,
what you'd build, which pieces to take and how to mix them, or I go to the strategy part, how to differentiate your product from other products, what to do with the roadmap. But essentially what you see here on the page, and I'll start from the second line, Getusermedia, that's essentially, well, what we want to do is to gain access to the camera and the microphone. That's the only thing it enables us doing. And that in itself is very useful. If you want to take a profile picture of a user, you can now just access his camera instead of asking him to upload an image. Mm-hmm. Not related to communication altogether. There are a lot of cool demos running around Getusermedia.
And the peer connection API, is that similar to how you would signal with WebSockets, or is that something else?
No, the peer connection is the media engine itself. Everything is a peer connection. After you have the media part, you shove it into the peer connection. The peer connection will take care of negotiation, eyes, turn, stun, whatever, and then sending and receiving the data. It does everything for you. Mm-hmm. That's the bulk of WebRTC is in the peer connection.
And it struck me as strange too that there's the web audio integration. I think it struck me as strange is because I assumed that would be part of the Getusermedia with video.
It's a different set of APIs. It's here, I'd say, even by mistake. Okay. And what I mean by that is the following. When you use Getusermedia and you access the camera, for example, mm-hmm. Okay, you can take the data and put it on a canvas. Now that it's on a canvas, I can play with WebGL on it and do stuff before I pass it around. Okay, so I can do visual effects. I can try using algorithms that will search for the eyes or movement or things like that. Web audio is an HTML5 API that does similar things that WebGL does to graphics, Web audio does to audio. And then I can use Getusermedia to get that audio and pass it into the web audio part.
I see.
Okay, so it's not really part of WebRTC, but web audio integration here means that you can actually take Getusermedia and connect it to web audio.
Okay, it'll allow you to do that through some method of kind.
Yes, I'm assuming that NTET added that into this page just because there was a time where Firefox didn't support it and Chrome did. Okay. They had that difference. Something that I think that they do with their Toki.io platform is check that there is volume on the microphone to understand if a microphone is actually connected and not muted before the call begins, so they can alert you that there's an issue.
Right.
Then the fourth one is the data channel. We haven't talked about this one at all, but we did say that WebRTC is peer-to-peer. None of you were that impressed, although that's like the only way you can send data today from browser to browser without going through a server.
Actually, I'm very impressed with the idea, at least, of data channels and what it can provide, because from my understanding, if I am in Israel and you are in Israel and we need to chat to each other, it's going to be very fast. If the server is in Japan, though, and we don't have a peer-to-peer connection, then
the data channel enables you to send whatever data you want directly across browsers, not going through a server.
Yeah.
And again, it's secured, blah, 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 blah. And then you see companies that are doing quite neat things with it. Either they build solutions that are secured because the server doesn't know anything, so it can't store metadata, or they build similar things to BitTorrent that allow augmenting CDNs or doing file downloads faster by using multiple peers downloading the same file, they start helping each other, things like that.
Yeah,
so a lot of interesting stuff is done with the data channel.
I could see use cases in finance for this too, in gaming. So you could do like, Bitcoin exchanges, transfer receipts, quickly, securely that way.
There is a company that is called BitPay. They're actually using the data channel. I think they're doing that to place multiple signatures on a Bitcoin to do signing there. There's a demo called Banana Bread made by Mozilla that shows a multiplayer game that uses WebRTC. There's another game called Werewolf something that uses WebRTC for the data channel. There's an Iranian developer that I've talked to during the Mondial who built a soccer game, but since he's in Iran, he had to use the data channel because AWS doesn't work that well. So he used the data channel so players can play his football game online in that way. So there are many uses for that. I think we're only scratching the first surface with it, but it's an enabler for a lot of things.
So if I understand the data channels correctly, if I am in Israel and you're in Israel, we are doing peer-to-peer. It's pretty fast. If we're not doing peer-to-peer, you and I are both in Israel, but the server is in Japan, then we're going to have some serious latency issues from what I understand. I love the idea of data channels, and I think it's really got a lot of potential. It's probably the most powerful piece, I think, in WebRTC, but I don't know because we haven't really tapped into the details of it. There's going to be that mind shift for people going peer-to-peer, having dealt with the history of torrents and all sorts of nastiness with peer-to-peer over the past few years, even decade, and it's gotten a bad rap. And not to say torrents are bad, they're actually very good. It's just they've gotten a bad rap because of privacy and copyright infringements. So are there any best practices out there currently for using data channels or any of these APIs that you could think of other than your blog?
There are no best practices there. There are a lot of unknowns even. Like, what is the speed that this can run with? How many connections can you run in parallel? When will the browser start breaking up? So these are quite unknowns today. But it's something to play with. I think it's the most interesting part of WebRTC today. It might be because I'm fed up with voice and video, working on it for so many years. Then inside this list, there's turn support, which is a feature of the peer connection. Echo cancellation is another feature of the peer connection. Okay, that's a given that you need that as part of a voice over IP solution, no matter what you're building. The media stream API is a new set of APIs that are being added to WebRTC, or should I say ORTC. It's actually part of WebRTC 1.1. And Google decided to roll some of it back and start deploying it.
What is that specifically?
So the main difference between WebRTC and ORTC is the SDP part. WebRTC is the media engine, and it started by Google acquiring a company called Gibbs, Global IP Solutions, that licensed the media engine to voice over IP company. What they did essentially was Gibbs provided an SDP API for their customers because most of the customers use the signaling protocol called SIP, and SIP uses SDP to negotiate parameters. So when we start a call in voice over IP, and I want to tell you, look, Eric, this is going to be a video call, and I don't know about you, but I know that the codecs that I'm supporting are G711 and let's say G722 for voice, and for video I'm doing H.264, but I can only do VGA resolution because that's the hardware I have. And then you need somehow to look at that information and see if that fits, and to send me back what your capabilities are. That's what goes inside the SDP, okay? So that's the API that Gibbs provided in the past. When Google went about saying we're going to build and standardize WebRTC, it was just there, so they probably said, well, let's use that as the API for now. The problem with SDP is that it's ugly. Not everyone understands, not everyone interprets the specification of SDP the same, so you have interoperability issues, and it's not as nice as JSON. So parsing it with JavaScript can be hellish. You use a lot of regular expressions. So people complained, and ORTC adds a media stream API that simply said, well, this SDP thing, we're going to do something else instead to make it easier for JavaScript developers. It's part of ORTC. Okay, so they're starting to introduce these media stream APIs. Multiple streams. If I want to send 5 video streams on the same peer connection, can I do that? Am I allowed to? That's the answer to the question.
Yeah, whether you're allowed to or whether you should are probably two different answers.
Whether you should depends on your use case. Allowed to means that Firefox doesn't support it, Chrome does. Simulcast Simulcast again is a feature of video. We're running here a Google Hangout, right? So all of us are sending the highest resolution we can to the Google Hangout server, and he is deciding what to send to each one of the participants. Now, Eric, I see you large on my screen, and Christian, because he's muted, is always in this small box over there. But he's sending high resolution to the Google Hangout server. Now, Google Hangout can decide to, well, we're going to decode that data, scale it down, then encode it, and then send it to everyone else. That's going to be a lot of, it's going to eat up a lot of resources. Or they can say the following, well, let's simulcast. Let's have each participant encode twice, once in high resolution and the second in a low resolution. And we're going to get these two streams and then decide which one to send to whom. So it's supported and not supported depending on the versions, and that's simulcast. Solid interoperability, I can't understand this one, because as far as I know, there are things in HTML that aren't solid interoperable for the last 4 or 5 years anyway. So this one, well, we're going to live with that. Browsers behave differently. We as developers need to be able to overcome these problems. This is why everyone, the first line of code he includes in his HTML page is, well, let's get jQuery over here to do things with the page. So that's going to happen with WebRTC, and there is an adapter.js to do that. Not as easy, but we're going to live with interoperability issues for the next several years anyway. Screen sharing is screen sharing. Yes, instead of using, or in parallel to the Getusermedia API, you can actually get the screen of the user and send that encoded as a video stream to the other side. Either the whole screen, an application, or a tab. The usual way you do that today. So it's, starting to be supported. Media constraints. I want to limit the resolution or the bitrate or whatever. These are things that are only half working between the browsers because they actually need to define it better, what it means. Stream rebroadcasting, I'm clueless about this one.
Maybe that's like where if the connection drops or there's some problem where somebody goes offline, that it can reconnect to the same spot.
Okay, I'm reading what they have there here in the description. So essentially, that for me, that's pipelining. How can I take one peer connection, stream it into another peer connection, and then send the same thing twice or move it in between connections? So that's something to play with once it's out. It is needed. And then ORTC API, that's WebRTC 1.1, which isn't, it's not even ready.
Right.
So that's about it from this page of is WebRTC ready yet? The easy answer, yes, it is, depending on the use case that you have.
It's actually pretty amazing how far this has come in just the last 2 or 3 years. And we definitely have a ways to go before you could just take it for granted that WebRTC is available in whatever environment you want and that it's perfectly interoperable with everybody else. But it's very encouraging to see how fast it's moving. What do you think are really the main challenges right now, the things that have to get sorted out before we get closer to that level where we are with HTML5, where there's some things that are goofy, but we can live with it?
Well, for me it's already there. I'm sorry. I'm using it daily. So again, for me it really depends on the use case. I'll tell you what I'm saying that, okay? We're now in 2014, okay, November. Are WebSockets ubiquitous today? Do you feel comfortable using that?
With fallbacks, yeah.
It's mainstream today for you?
Fairly.
Okay. So I'm looking at a post now from Joel on Software. Joel Spolsky, he wrote a blog once, a very popular one. Mm-hmm. He's the guy behind Trello and Fog Creek and some neat technologies. So he has a post from 2012, January, called How Trello is Different. And one thing that they did was use WebSockets, and he's saying, well, we're on the cutting edge of technology. We're using WebSockets. Okay, so for me, that's an eye-opener. I'll put that as a link so you can put it in the end.
And that's only 2 years ago. So
exactly.
That's pretty awesome.
So, there is a new technology called WebRTC. It's not even standardized yet. We're already using it on the web, and we're complaining that it's not ready. I mean, let's be fair. We've got video conferencing for 20 years now, and it doesn't work yet.
So, that kind of speaks to the fact that a lot of these companies have so many different choices, and ultimately they're going to choose what works best internally for them, for their product, and for what they're doing. So they may look at WebRTC and say, well, we're using Internet Explorer mostly. We don't have Chrome, so why should we even look at this technology? Even though they could use it, in fact, doing one of the other techniques that you spoke about. And I can't imagine that you have clients that you're going into, they're all on Chrome. I can't imagine that at all. So I hope that you're absolutely right. And I think it'll be a fantastic thing if you are, that in 2016 we look back and say, wow, WebRTC is just every day. How did people not use this before?
So a few things about that. The first thing is we have today Chrome, well, we've got Google, Mozilla, and Microsoft essentially supporting WebRTC. Two of them provide that in the browser today. Microsoft said that they're on board. So this is happening. It's not going away. Apple will join one day, who knows when, iOS 18 or something. They will decide to add support. But essentially it's here to stay. And then as a company you have three options. Either to use it, you can then decide, well, I'm going to use it, and where it doesn't exist, I'm going to either use Flash as a fallback, or I'm going to use a plugin as a fallback, or you can say I'm not using it. But if you're saying I'm not using it, I would say, what is your competition doing? Are they going to make the same decision? If you're comfortable with that fact, then fine. And if not, then you need to revisit your decision.
So like companies like Amazon, right? They're doing work with, Amazon is doing
Mayday?
Mayday, thank you. So Mayday is only on Kindle certain hardware. And so my understanding is they use some of the bits of WebRTC based on our talk with Aaron Syme last time. And
so let's go back. Amazon Mayday.
So yeah, let's talk about that then.
You're Jeff Bezos. You're going to release a tablet to the market.
Right.
You need a differentiator, and you need something that is easy to develop. And then you come up with this technology called WebRTC, and you say, I'm going to do the following. I'm going to take, the Kindle Power is essentially an Android device.
Right.
So Google is investing the money for me to put WebRTC inside it. I've got a media engine there. I can use it, voice, video, whatever. That's a good thing for me. The second thing is, I'm a vertical company when it comes to the tablet, because I sell the tablet, I sell the media for the tablet, I sell the apps on the tablet, I'm the e-commerce platform for the tablet, and I'm also providing support for the tablet. I'm the service provider himself. I've integrated vertically everything. If I provide specialized support for that tablet, it means the following. I can now offer something that no one else can. Why? Because if I'm Apple, I don't care about my customers anyway, so I'm not going to put a contact center specifically for them. If I'm Google, I own the operating system, but not the hardware. I need to work with these weird companies like Samsung and LG, and they like to do stupid things on their hardware, so I can't control that either. So I can't build such a thing into the Android operating system. If I'm Samsung or LG, I couldn't care less about customer support. I tried reaching out for them because I bought a Galaxy Tab 4 for my sister. It doesn't work. I have no one to turn to. And then that's a true story, because I purchased it in the US, and in Israel they've got the worst customer support ever. And they're not built to offer services, they're built to sell devices. And if I'm the service provider, pick any one of them, they have the contact center, but they can't put anything on the smartphones, not in a way that it's so integrated into the operating system. So Amazon here has something that nobody can do. It's a real differentiator. And they took it to the extreme. They said, we're going to put here customer support. We're selling online self-service, so we're not used to doing these things in, real support with humans. We are going to do it in video. So we're not only taking the risk of doing it voice, because voice is easy. We can outsource everything to India anyway. We can't outsource everything to India if we're doing video. And we're going to do one more stupid thing. We're going to say that the average wait time is going to be less than 15 seconds. They reach below 10 on average. They have 9.7 or something like that. So they couldn't have built it. They could have built it without WebRTC, but it would have taken a lot more time. So that's a win for them. At the end of the day, if you look at it, you can say, that's not WebRTC at all. But it is. It includes WebRTC as a technology. It's a closed solution. It's a silo, which is how WebRTC works most of the time anyway. And without it, it would have cost them more to build. So it enabled them to do something they couldn't have done earlier and come with a real differentiator and something new that is now existing in the market.
So I did want to ask, on the IoT, Internet of Things and Internet of Everywhere idea, does it make sense to use WebRTC for the Internet of Things with all these connected devices in your homes? Because there's a lot of different low-level protocols and energy requirements and bandwidth requirements that really we kind of take for granted in the web space that IoT is just not capable of. Do you think that WebRTC makes sense for this? Because it does seem like it would be very powerful for something like smartphones, which are basically mini computers, but for your average Arduino board or something like that, it may not. What are your thoughts on that?
If you look at most of the topologies today of Internet of Things, they end up going to large backend servers to send all the sensors data in and then run big data analytics on that information. Okay, so there is no need for communicating locally anyway. It goes through a centralized server. So the topologies that we're building today in the Internet of Things doesn't play well with WebRTC. You don't need it there. You've got WebSockets there already and you're fine. Maybe inside a connected home, when you say I'm going to have the home device, blah, 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 it might make sense. But even then, you can put an OJS server in there and then you've got a local solution that doesn't require something like WebRTC. The only reason to use WebRTC as part of your stack when you use Internet of Things is that you're going to use JavaScript and HTML developers, and it's going to make it easier to build such use cases if you need them. The other reason, if you need voice and video, because it's accessible through WebRTC. If you ask me, it will be less than 2% of the use cases of the Internet of Things to use something like WebRTC.
I do have a question about codecs, the VP8, VP9, and H.264 and 265. And can you tell us about these different codecs and about what the motivations for them are, and why is there this war between these standards going on right now?
Okay, so technology-wise, they are the same. If you find me a single person that can look at a VP8 VP8 video stream being played versus an H.264 video stream being played and say this is VP8 and this is H.264, that would be a miracle to find such a person.
That's like a great party trick.
They do the same thing, they do it in the same quality, and then you can, it's going to be a pissing contest where nobody really wins. So that's the differences that they have between them. It's irrelevant. So it's 5% for that for CPU and 5% bitrate for that. Who cares? And then you've got VP9 versus H.265. It's going to be the same old story. The whole issue here is a business issue. It has nothing to do with technology. And there's, I'd say, two main things in there. The first one is ecosystem. H.264 is a huge ecosystem. Companies invested in it for the last 10 years or so. So if you're Cisco, you're doing, telepresence, and you have set-top boxes because you acquired two companies, NDS in Israel and something Atlantic, I don't remember the name, for set-top boxes. You have huge investments in something like H.264. And if someone comes and changes that to some other codec, you need to reinvest a lot. And you have headache of how do you connect to existing hardware out there. So there's that part of the incumbent, the problem of switching a technology. And then there's the part of, patents and barrier of entry. When it comes to H.264, it is an expensive codec. You need to pay royalties for that, for patent holders, and you pay to the MPEG-LA. And what I've seen the other day, which was, for me, it was like, whoa, I didn't know it was that high. Let me find it. It's something like Telco 2.0 is a blog that deals with the telecom industry. And they did a post recently about the cost of royalty costs of different codecs. Essentially, in the table that they had there on their website, it was around $10 on a phone to put H.264. That's how much needs to be paid to someone. Wow. So think about it. The phone costs $600. A lot of it, or let's say like 2 or 3% of it, is going for a single video codec. That's ridiculous. That's ridiculous if you ask me. Okay, so, and companies are either making money out of that or ensuring that they will not have any new entrants into this market that are going to disrupt. So their business model is secure just because there is a price attached to a codec. WebRTC came out and said we're not going to use a codec that requires paying royalties. We're going to try and use something like WebRTC, like VP8 instead. And VP8 is, again, it came from an acquisition of Google. They acquired a company called On2. On2 had the VP7 codec and they were working on VP8. And then they released that codec. It's a royalty-free codec, essentially. There are companies that say that they have patents on it, and these are disputes that will end up at one point in time or another. Who knows when? But I'd say that the main two, let's say, challenges here or differences between H.264 and VP8 are, first of all, paying for royalties. So that's a barrier of entry. And the second one is existing ecosystem or existing deployments, where people are comfortable with what they know and use and don't want to switch to something that is an unknown for them.
So with technologies that don't have full support in the browser, we kind of have to consider deployment pretty early on in the stages of development, because you don't know, it may work in development and then you get into production, you might have gotchas, edge cases and problems that could cost you a good amount of time for your sprints near the end. And that's the most critical time usually. So are there any gotchas or edge cases that you could think of when deploying this, or does it just work out of the box?
There are a lot of catches and things you need to know. So there are a lot of things that you need to learn in the architecture part, but I would say the following. If you come with a voice over IP education, it's going to be more challenging for you because someone already taught you how things need to look like, and they might not be correct, especially not when you switch and think about the web. The web is different than voice over IP, so the deployment is going to look different as well.
Is there any resources developers can go to find out more about that?
My blog. Not really, but the way you scale in voice over IP is different than how we would do it in the web. And when you talk to companies, you see these differences.
If people want to learn more about WebRTC, obviously they can go to your blog and they can read all of the awesome posts that you have. But if they want to find you, contact you, talk to you more about this, how can they catch you? Are you on Twitter or Google or?
Yes, and also the contact page on my whatever.
Okay. And what's your Twitter handle?
TSAHIL.
Is there anything that we haven't covered that we should?
A lot, but I think we don't have the time for it.
Excellent. Tsahi, I know it's really late over in Israel right now, really late for parents and those who have children, but I personally appreciate you taking the time to come on our show and talk with our listeners about all that you know and your experience with WebRTC, being as you're such a prolific figure in that space. So thank you so much for coming on.
Sure. Thanks for having me.
Thank you. This episode was edited and produced by Greg Meadows and Red Cloud Services. Red Cloud Services provides D3 data visualization to government agencies and commercial clients. And to see a demo, visit redcloudservices.com. That's redcloudservices.com. And thanks again, Greg. I really appreciate all your hard work on this. This episode comes to you, at least in part, through the support and sound equipment generously supplied by 3 Pillar Global. 3 Pillar is a software product development company in Fairfax, Virginia, and 3 Pillar is a leader in creating purposeful and innovative product experiences. 3 Pillar was recently named to the Washington Post Top Workplaces list for 2014. So if you want to follow 3 Pillar on the Twitters, it's at 3 Pillar Global. And to find out more and see current job openings, please visit 3pillarglobal.com. That's 3, the number, pillarglobal.com.